Unveiling the Code of Life, a historical perspective. Gregor Mendel's pea plant experiments laid the groundwork for genetics. Watson and Crick's discovery of DNA's double helix in 1953 revolutionized molecular biology. The dawn of gene editing, from simple scissors to CRISPR-Cas9, discovered in 2012, offers unprecedented accuracy and efficiency. This technology has democratized gene editing, accelerating advancements in medicine and agriculture. "2030, a new era of genetic medicine. Gene editing promises to eradicate inherited diseases and personalized treatments. Advancements in CRISPR technology are paving the way for groundbreaking medical breakthroughs." CRISPR, the engine of genetic revolution. CRISPR-Cas9 acts as a programmable scalpel for DNA, enabling precise gene editing. Clinical trials are exploring its potential to treat various diseases and improve agriculture. Section 2. Beyond CRISPR, exploring the expanding toolkit. New CA's enzymes and techniques like base and prime editing offer unique capabilities. These tools enhance precision and expand the scope of gene editing possibilities. Section 3. Precision engineering, gene editing at the base level. Base editors rewrite DNA letters, correcting genetic errors without cutting DNA. This approach minimizes unintended alterations, enhancing safety and accuracy. Section 4. Delivery dilemmas, getting CRISPR to where it matters. Effective delivery methods like viral vectors and lipid nanoparticles are crucial. Overcoming delivery challenges is key to realizing gene editing's therapeutic potential. Rewriting the future, gene editing and medical breakthroughs. Gene editing is transforming medicine, making personalized gene therapies a reality. Clinical trials are underway for a wide range of diseases, accelerating medical advancements. A world without inherited diseases, turning off genetic fate. Gene editing offers the possibility of eradicating inherited diseases by correcting faulty genes. This technology holds the potential to rewrite genetic fate, offering hope for a healthier future. Beyond single genes, tackling complex diseases with CRISPR. Gene editing targets complex diseases like cancer and Alzheimer's with precision. CAR T-cell therapy and other approaches are showing promise in clinical trials. Section 4. The personalized medicine revolution, tailoring treatments to your DNA. Personalized medicine tailors treatments to individual genetic profiles. This approach optimizes efficacy, minimizes side effects, and enhances disease prevention. Section 1. The ethical tightrope balancing progress and responsibility. The rapid advancement of gene editing technologies has ushered in a new era of scientific possibilities, but it has also ignited a firestorm of ethical debate. Like a tightrope walker, navigating a precarious path, society must carefully balance the immense potential benefits of gene editing with the profound ethical implications it raises. The decisions we make today will shape the genetic landscape for generations to come, making it imperative that we proceed with caution, foresight, and a deep sense of responsibility. At the heart of the debate lies the fundamental question: how far is too far? While few would argue against using gene editing to alleviate human suffering by curing devastating genetic diseases, the prospect of using this technology for genetic enhancement, essentially designing babies with desired traits, raises a myriad of ethical concerns. Where do we draw the line between therapy and enhancement? The potential for exacerbating existing social inequalities is another pressing concern. If gene editing technologies become widely available, but access is limited by cost or other factors, it could create a genetic divide, further marginalizing already disadvantaged communities. Ensuring equitable access to these transformative technologies is paramount to preventing a future where the benefits of gene editing are enjoyed only by the privileged few. The ethical considerations surrounding gene editing are complex and multifaceted, demanding thoughtful deliberation and a nuanced approach. Open and transparent dialogue among scientists, ethicists, policymakers, and the public is crucial to navigating this uncharted territory responsibly. The future of gene editing hinges not only on our scientific prowess, but also on our ability to wield this powerful tool with wisdom, compassion, and an unwavering commitment to the well-being of all humankind. Section 2, the designer-baby dilemma, navigating the uncharted waters of genetic enhancement. The prospect of using gene editing to enhance human capabilities has fueled both excitement and apprehension. Imagine a world where parents could select their child's traits before birth. This scenario forces us to grapple with profound ethical questions about human autonomy and diversity. Proponents argue it could lead to a healthier, more capable society. They envision a future where genetic diseases are eradicated and human potential is maximized. Critics raise concerns about creating a genetic divide, further marginalizing the disadvantaged. The ethical considerations strike at the heart of human identity and autonomy. Does selecting traits undermine a child's right to an open future? What happens to the value of diversity in a world of uniformity? The ethical debate is complex, requiring careful consideration of benefits and risks. As we venture into this territory, we must engage in thoughtful dialogue and proceed with caution. The transformative potential of gene editing technologies holds immense promise for improving human health and well-being. But this promise will remain unfulfilled if access to these technologies is limited to a select few. As we stand on the cusp of a new era in medicine, it is imperative that we prioritize equity and accessibility, ensuring that the benefits of gene editing reach all corners of the globe, regardless of socioeconomic status, geographic location, or any other factor that could create a barrier to access. The high cost of developing and delivering gene editing therapies poses a significant challenge to equitable access. If these life-changing treatments are priced beyond the reach of ordinary citizens, it will create a two-tiered healthcare system where the wealthy can buy their way to better health, while the less fortunate are left behind. Addressing this challenge requires a multifaceted approach involving collaboration among governments, healthcare providers, researchers, and pharmaceutical companies. Policies that promote affordable pricing, encourage research and development in underserved areas, and provide financial assistance to patients in need are essential to bridging the access gap. Beyond cost, other barriers to access, such as lack of awareness, cultural stigmas, and inadequate healthcare infrastructure, must also be addressed. Education and outreach programs that raise awareness about gene editing technologies and their potential benefits, particularly in underserved communities, are crucial to ensuring that everyone has the opportunity to make informed decisions about their health. Furthermore, strengthening healthcare systems in low-resource settings is essential to making gene editing therapies available to those who need them most. The future of gene editing hinges on scientific advancements and public perception. It has sparked hope and apprehension, igniting public discourse. Educating the public is paramount for informed decision-making. Open communication builds trust and addresses concerns. Scientists must engage clearly and accessibly. Media should report accurately and responsibly. Education should integrate gene editing early. Public forums provide opportunities for dialogue. Museums can make gene editing accessible. Shaping gene editing's future is a collective endeavor. The promise of gene editing once a distant glimmer on the horizon of medical possibility, is now coming into sharper focus as real-world success stories emerge from research labs and clinical trials. These inspiring accounts of lives transformed by gene editing offer a glimpse into a future where diseases that once seemed insurmountable are being challenged and overcome with unprecedented precision and effectiveness. One such beacon of hope shines from the field of inherited blood disorders. In a groundbreaking clinical trial, several patients with beta thalassemia and sickle cell disease, debilitating conditions that affect red blood cell production, experienced remarkable improvements after undergoing experimental gene editing therapy. Prior to treatment, these individuals required frequent blood transfusions to manage their conditions, a demanding and often risky regimen. However, following gene editing therapy, several patients experienced a dramatic reduction in or even complete elimination of their need for transfusions. These individuals, once tethered to a life restricted by their conditions, are now able to live more freely, their bodies producing healthy red blood cells for the first time. These early successes, while still preliminary, have ignited hope for a future where inherited blood disorders are no longer a life sentence, but a treatable condition. The impact of gene editing extends beyond blood disorders, offering hope for individuals and families grappling with a wide range of genetic conditions. Children born with severe combined immunodeficiency, a rare genetic disorder that leaves them highly susceptible to life-threatening infections, have experienced remarkable recoveries after undergoing experimental gene therapy. These children, once confined to sterile environments to protect their fragile immune systems, are now able to live more normal lives, their bodies equipped to fight off infections like other healthy children. From lab to life, real-world applications of gene editing today. While the most widely publicized applications of gene editing often center around treating human diseases, the impact of this revolutionary technology extends far beyond the realm of medicine. From agriculture to environmental science, gene editing is being harnessed to address some of the world's most pressing challenges, offering innovative solutions that have the potential to reshape our relationship with the natural world. In agriculture, gene editing is being used to develop crops that are more resistant to pests, diseases, and harsh environmental conditions. This is particularly crucial in the face of climate change, which is expected to exacerbate existing agricultural challenges by increasing the frequency and severity of droughts, floods, and other extreme weather events. By engineering crops that can withstand these challenges, scientists hope to enhance food security and improve the livelihoods of farmers worldwide. Gene editing is also being explored as a tool to reduce the environmental footprint of agriculture. By engineering crops that require less water, fertilizer, and pesticides, scientists hope to minimize the environmental impact of food production, promoting more sustainable agricultural practices that are in harmony with the planet. Beyond agriculture, gene editing is showing promise in addressing environmental challenges such as pollution and biodiversity loss. Scientists are exploring the use of gene editing to engineer microorganisms that can break down pollutants, offering a potential solution for cleaning up contaminated environments. Others are investigating the use of gene editing to control invasive species, protect endangered species, and even resurrect extinct species, aiming to restore balance to fragile ecosystems. The gene editing pipeline, promising therapies on the horizon. The field of gene editing is brimming with excitement and anticipation as a wave of promising therapies moves from the laboratory bench to clinical trials, offering hope for individuals and families grappling with a wide range of debilitating and often fatal diseases. The gene editing pipeline is robust and diverse, encompassing therapies for inherited disorders, infectious diseases, and even complex conditions like cancer and heart disease. One area of intense research focuses on developing gene editing therapies for neurodegenerative diseases such as Huntington's disease, Alzheimer's disease, and Parkinson's disease. These devastating conditions, which rob individuals of their cognitive and motor functions, have long posed significant challenges for traditional treatment approaches. However, gene editing offers a glimmer of hope by targeting the underlying genetic causes of these diseases. Scientists are exploring the use of gene editing to correct the faulty genes that lead to the accumulation of toxic proteins in the brain, a hallmark of many neurodegenerative diseases. By removing or silencing these harmful genes, researchers hope to slow or even reverse the progression of these debilitating conditions, offering hope for preserving cognitive function and improving quality of life for those affected. The gene editing pipeline is also teeming with potential therapies for inherited metabolic disorders, a group of rare diseases that disrupt the body's ability to break down and utilize certain nutrients. These disorders, often diagnosed in infancy or early childhood, can lead to serious health problems, including developmental delays, organ damage, and even death. Gene editing offers the potential to correct the genetic defects that cause these disorders, providing a chance for affected individuals to live healthier, more normal lives. Beyond medicine, gene editing's impact on agriculture and beyond. While the medical applications of gene editing continue to capture headlines and fuel public imagination, the transformative potential of this technology extends far beyond the realm of human health. Gene editing is poised to revolutionize agriculture, offering innovative solutions for enhancing crop yields, improving nutritional content, and making food production more sustainable in the face of a changing climate. Imagine a world where crops are engineered to thrive in harsh environments, requiring less water, fertilizer, and pesticides. Gene editing is making this vision a reality, paving the way for a more resilient and sustainable agricultural system that can feed a growing global population without further straining the planet's resources. By enhancing drought tolerance, increasing nutrient uptake, and boosting resistance to pests and diseases, gene editing is empowering farmers to produce more food with less environmental impact. Beyond simply increasing yields, gene editing is being used to enhance the nutritional value of crops, addressing micronutrient deficiencies that affect billions of people worldwide. Imagine rice enriched with vitamin A, a crucial nutrient for vision and immune function, or tomatoes packed with antioxidants that protect against chronic diseases. Gene editing is making these possibilities a reality, offering a powerful tool for combating malnutrition and improving public health. The applications of gene editing extend far beyond the farm, reaching into the realms of biomanufacturing, energy production, and even materials science. Scientists are harnessing the power of gene editing to engineer microorganisms that can produce biofuels, bioplastics, and other valuable materials in a more sustainable and environmentally friendly manner. The potential applications of gene editing are vast and varied, limited only by our imagination and our commitment to responsible innovation. The precision paradox, off-target effects, and unintended consequences. Gene editing, particularly CRISPR-Cas9, is often lauded for its precision. However, off-target effects where unintended edits occur remain a significant concern. These off-target cuts might be minor or severe depending on their location. Even minor off-target effects could disrupt cellular function, potentially leading to diseases like cancer. The risk of unintended edits remains, especially in regions with repetitive sequences. Rigorous testing and monitoring are crucial to ensure the safety of gene editing therapies. The CRISPR conundrum. Ethical considerations in a world of genetic power. CRISPR-Cas9 has ushered in a new era of genetic power, allowing us to alter the building blocks of life with precision. This power presents an ethical conundrum, forcing us to confront questions about human nature and societal values. Germline editing altering sperm, eggs, or embryos raises concerns about unintended consequences for future generations. Designer babies with enhanced traits could exacerbate social inequalities. Open dialogue among scientists, ethicists, policymakers, and the public is essential for ethical guidelines. The gene editing divide, ensuring equitable access to transformative technologies. Gene editing holds immense promise for improving health, but this promise will remain unfulfilled if access is limited to a privileged few. We must prioritize equity and accessibility, ensuring benefits reach all corners of the globe. The high cost of gene therapies poses a significant challenge. Bridging the divide requires collaboration among governments, healthcare providers, and pharmaceutical companies. Policies that incentivize affordable therapies and provide financial assistance are crucial. Education and outreach programs are essential to raise awareness. Strengthening healthcare systems and improving access to medical technologies is crucial. Navigating the genetic labyrinth, balancing innovation with precaution. Gene editing offers transformative medical breakthroughs, but also potential unintended consequences. We must balance audacious innovation with cautious prudence, respecting the complexities of the human genome. The allure of curing diseases and enhancing human capabilities is both exhilarating and daunting. However, the human genome is a complex web evolved over millions of years. Altering it carries inherent risks we are only beginning to understand. Ethical implications, especially germline editing, demand thoughtful deliberation. Collaboration among scientists, ethicists, policymakers, and the public is essential. Establishing ethical guidelines ensures responsible use for the benefit of all humankind. The Gene Editing Odyssey, a journey into the future of humankind. Our exploration of gene editing has taken us on an extraordinary odyssey, a journey into the very heart of life itself. From Mendel's pea plants to the discovery of DNA's double helix, we have witnessed a scientific revolution. CRISPR-Cas9, a molecular scalpel, offers hope for curing inherited diseases. Each advancement brings us closer to personalized medicine tailored to our unique genetic makeup. This journey is about grappling with profound ethical questions and the responsibility of altering life. The Gene Editing Odyssey is a testament to human curiosity and our desire to improve the human condition. A new era of medicine. Embracing the promise, navigating the challenges. Gene editing has ushered in a new era of medicine, one where the once unimaginable is becoming reality. We stand on the cusp of a future where inherited diseases, long considered insurmountable obstacles, are being challenged and overcome with unprecedented precision and effectiveness. The gene editing pipeline is brimming with promise, offering hope for individuals and families grappling with a wide range of debilitating and often fatal conditions, from inherited blood disorders to neurodegenerative diseases to various forms of cancer. The potential benefits of gene editing extend far beyond treating diseases, encompassing the realms of diagnostics, drug development, and even organ transplantation. Imagine a future where genetic screening at birth provides a personalized roadmap of an individual's health risks, enabling proactive interventions and personalized medicine tailored to their unique genetic makeup. Envision a world where gene editing is used to grow organs for transplantation, eliminating the long waiting lists and the risk of organ rejection. Yet alongside this wave of optimism, we must acknowledge the challenges and ethical complexities that accompany this transformative technology. Off-target effects, unintended consequences for future generations, equitable access to these potentially life-saving therapies, and the potential for genetic enhancement are just a few of the issues that demand careful consideration and thoughtful dialogue. Embracing the promise of gene editing while navigating its challenges requires a balanced approach, grounded in scientific rigor, ethical awareness, and a commitment to social responsibility. It requires collaboration among scientists, ethicists, policymakers, and the public to ensure that this powerful technology is used wisely and for the benefit of all humankind. Shaping our genetic destiny, a shared responsibility for a healthier future. The gene editing revolution is a defining moment in human history, reshaping our relationship with life itself. The decisions we make today will shape the genetic landscape of humanity. It demands careful consideration of the potential benefits and risks. The Gene Editing Odyssey is a shared responsibility for the greater good. Let us proceed with optimism and caution, guided by ethical conduct and social responsibility.